HP really takes the sunk cost fallacy seriously.
Welcome to Tech Tales. I'm here with Zach. Say hi, Zach.
Hi.
Hi. Today we're going to be talking about Intel Itanium, which was going to be the next big processor architecture for servers and super powerful workstation PCs. And it was eventually going to be the chip design that would be everywhere. And that did not happen. Have you heard of Itanium, Zach? Do you know anything about this?
I've heard a bit about it. I know there's still the occasional program that's compiled for Itanium instructions for some reason.
Yeah, so the story of Itanium starts in 1986 when HP releases its own CPU architecture called PA RISC. And this is back when several companies were developing their own computer and server hardware along with their own chip designs, which is different from today, where really the companies that make the computers and finished boxes and servers aren't the ones making the chips. Intel's not making laptops, really. So HP's architecture was primarily focused on high-end workstations and servers. But in 1989, some engineers at HP started to believe that reduced instruction set chips like theirs would eventually run out of steam, that they'd eventually hit this limit where they really couldn't make them any faster because they only executed one command at a time for the most part.
What are you, defining a reduced instruction set as? Is that like the bits or just the number of operations it can do natively?
So RISC stands for Reduced Instruction Set Computer, and RISC designs are CPUs that have a small but highly optimized set of instructions that execute very quickly. So the idea is that the chip itself can't do a lot, but what it can do very quickly. So the programs can send it commands that will execute very quickly. And some examples of that sort of design is like PowerPC, which is eventually used in Apple Macs for the late 90s and early 2000s, and also in like the Xbox 360 and PS3. And also ARM, which is on almost every single phone and tablet. Intel and HP announced a partnership in June 1994 that they were going to work together to create a new processor technology. And the partnership was focused on 64-bit processors and a new semiconductor process. Intel was willing to develop the new architecture mostly themselves with some help from HP, under the assumption that it would be used by the majority of high-end computers. So the idea was that like every single server and every high-end workstation would use these chips. And the first generation of these new chips had a target launch date of 1998. These new chips had a design that HP and Intel called EPIC, which stands for Explicitly Parallel Instruction Computing. Basically, the idea was that the CPU depended on the compiler, which is the program that creates machine code for the computer. It depended on the program to send it many instructions at once, which it would then execute in order. And the hope was that this would create CPUs that were less complicated to design and could eventually, they could add more functions to it. So HP and Intel announced this new partnership in 1994. In 1996, several other companies start to get excited for it. Compaq announced in October 1996 that they would ship systems with the first generation of chips. Dell promised to start porting software to it in 1997. And then also the same year, Sun Microsystems would start bringing its Solaris operating system to the design. In 1999, CERN, HP, IBM, Intel, Red Hat, and other companies started to port Linux to the new chip because this was when Linux was really taking off in servers and high-end workstations. And they wanted a Linux port ready on day one. And they actually got that because support for the new chips were integrated into the Linux kernel more than a year before the new chips came out because the chips were delayed.
So they had the entire architecture spec, but they didn't have any hardware for it?
Yeah. Like they finished a simulator for it before the actual hardware was anywhere near ready, which is kind of interesting.
Yeah.
So then in 2000, Intel reveals the name for this, which is Itanium. Sounds cool. Sounds futuristic.
It certainly does.
Yeah. We're in 2000, and these new fancy chips have still not started shipping yet. But that year, Sun and Intel actually stopped working together because the competition between them in the server space starts to heat up and they don't really want to support each other. Intel was focusing more on Windows 2000, Linux, and Linux derivative called Monterey for their chips. And Sun was doing its own thing with the Solaris operating system and its UltraSpark processors. There was some reports at the time that kind of said like Sun wasn't really ever serious about this.
They're also already 2 years delayed on something that took 12 years to come out originally. Yeah.
In the same year, in 2000, AMD released the specification for x86-64, which was an extension to Intel's own x86 architecture that they were using on desktops and servers at the time. And this was intended to compete with Itanium. Finally, in July 2001, Intel ships the first Itanium processors. However, I know this will maybe be a shocker, but performance was not better than really anything else that was out there. This first generation was sort of like a little bit of a prototype, almost.
A little bit of a disappointment.
Yeah, even though, like you said, like we're already very late on this, and
it's the Galaxy
AMD.
Fold.
Yeah, and AMD is now trying to compete with it too. So I'm gonna send you a report from the EE Times from July 4th.
All right, so the wait is over. 7 years, almost to the day, after Intel and Hewlett-Packard first announced their partnership, Itanium systems are ready to roll off production lines. This is the day Sun Microsystems has been dreading. Through all the years of Itanium hype, missteps, and delays, Sun has touted its message of software compatibility while spreading fear and doubt about Itanium. Over the next several months, at least 20 vendors will introduce Itanium systems. Intel's investment in the Itanium family continues, with 6 new versions in the works. That's a lot of versions for something that doesn't even work properly. Initial benchmarks show Itanium is not the disaster competitors had hoped for. The 800 MHz processor delivers strong performance on many key transaction processing and scientific applications. This was 2001?
Yes.
Didn't we already have, like, gigahertz processors then? For the higher-end stuff that this is supposed to be targeting?
I'd have to look.
Let's see. 2000. From AMD. Alright. True, the chip is not as good on basic integer applications. And Itanium's x86 performance is so bad that Intel won't even talk about it. Oh boy. McKinley Itanium 2, which Intel is testing, will double Itanium's performance, making it the lead. That doesn't seem to follow. It's not as good as basic integer applications, and x86, I guess it would be emulation, is
yes.
Terrible. But a doubling of performance of terrible, so terrible that Intel won't even talk about it, probably won't bring it to the lead.
Probably.
Itanium's toughest competition comes not from Sun, but from its own Pentium 4 processor. At 1.7 gigahertz, the x86 chip delivers better integer performance and more memory bandwidth than Itanium. Intel has delayed its Pentium 4-based Xeon for servers, but once available, that processor should deliver a better transaction processing performance than Itanium. So, Intel already has a processor that's so much better than this, unless you need 64-bit.
Yeah.
Interesting.
This is a big reason why Itanium never takes off, and we'll get into the next big reason in a second here. But the whole time Intel is pushing Itanium, they're also still selling Xeon servers with their normal x86 chips that, the same design that you'd find on any home PC at the time, just with more cores and a faster clock speed. So this whole time they're competing with themselves. And that's fine if Itanium has a reason for people to pick that over older chips or over the existing x86 chips. And that just never happens.
Yeah, I mean, like, it's kind of ridiculous. Like, you can't make a new architecture and then not have it still be able to run applications for the popular architecture. Like, we're seeing that with the ARM transition now. Like, MacBooks are all being based on ARM now, but Apple worked really hard to make that emulation layer that apparently works really well. And it looks like Intel couldn't do that with Itanium.
Yeah. During the first 2 quarters, Itanium is available. Only 2,601 servers were shipped with Itanium chips in them.
That's units, not models?
That is units. Those are servers being shipped out of factories with Itanium chips in them.
Oh boy.
Yeah, so that's not like completely unexpected, because in a server environment, you want something that's very rock stable, and it's something that's established technology that all your stuff works with. And Itanium was none of those things.
And none of the new stuff had been tested on physical hardware, right?
Yes,
it was just
correct.
All this should work.
Yeah, so the 2,600 number, it's not great, but it's also sort of in line with what I think Intel and HP expected. So the next big evolution for Itanium actually just comes a year later when Itanium 2 is released, and this is what was codenamed McKinley. And this was a 180 nanometer fabrication.
Wow, we've come a long way.
We've come a very long way. And it had clock speeds of up to 900 megahertz, which is still not
slower than the things that came out 2 years ago.
Still not the 1.7 gigahertz Pentium 4. And then I'm skipping ahead a little bit, but Itanium's dual core upgrade is also delayed, and that doesn't come out until 2006.
Wait, all of this was single core?
Yes.
Weren't Xeons multiple core then?
I believe so. So the next year in 2003, AMD releases its Opteron server processor. And this is the first widely available CPU with AMD's 64-bit extension. Opteron had full compatibility with existing x86 software and operating systems, while also supporting 64-bit software. And that was a huge improvement compared to Itanium, which could only emulate x86 software at slower speeds.
Yeah, I mean, it kind of seems like the best way to do 64-bit is what AMD did, because it's an extension, not a replacement.
Yeah. And then a year later, AMD released the Athlon 64, which was for home computers. The computing industry really starts to prefer AMD's architecture over Itanium, just because...
Can't imagine why.
Yeah. Yeah. Just because AMD's design was so much easier to develop for, and more importantly, it could run existing software with no performance penalty. Like, you could install 32-bit Windows and 32-bit database applications, and they would work pretty much as well as they would on x86 chips. So very quickly, Linux, FreeBSD, and Windows are ported to x86 64. And Intel is a little bit hesitant to implement this because, they're trying to push Itanium. The original goal for Itanium was what AMD is doing, which was it was going to start out on high-end computers, but it would eventually be everywhere. Intel eventually releases its own Xeon CPUs with those extensions in 2004.
Imagine spending over a decade to develop a new architecture, and then someone else comes and just extends the existing one.
Yeah. And it's especially funny because AMD all this time has had to license the x86 design from Intel, and now Intel has to go to AMD and license their add-on.
Oh, that's confusing.
So this is around the time where Itanium's potential just starts to evaporate completely. Like it was already not super attractive for servers and developers and everyone else. But 2005 is really where it starts to fall off a cliff and there's no return. So in that year, Dell stopped selling Itanium servers, which left HP as the only company still doing that, which, HP is still doing it because they put all this money and resources into it. That same year, Microsoft said that Longhorn, which was the code name for what would eventually become Windows Vista, would only support Itanium for databases and line of business applications. So when you would run Windows Server on Itanium, it couldn't do SharePoint, it couldn't do file and print servers, it couldn't do Windows Media Services. So a lot of the reasons someone would want to set up a Windows server. So by 2007, there were around 55,000 Itanium servers that were sold up to that point.
After 6 years.
Yes. And by that point, over 400,000 servers with various RISC architectures had shipped, and also 8.4 million x86 servers.
How many generations did they have by now? Did any of those 6 pan out?
The only big upgrade by this point was that Itanium 2 architecture. But again, like the dual core chips started shipping in 2006. So that was a little bit of an upgrade, but it wasn't like a massive redesign. It was just we added another core.
Copy and pasted the CPU.
And, also by this time, Intel had been selling CPUs for both servers and home computers that had AMD's extensions, first under the Pentium 4 line and then with the Intel Core series. The wind was already blowing in AMD's direction, and by this time Intel's like, okay, whatever.
Kind of seems like if they had released when they planned to release, they could have done at least a little bit better. 1998, 16-bit was still common, wasn't it?
It would have been a couple years before then, because Windows 95 was mostly 32-bit. So we were pretty past the 16-bit era. But yeah, 64-bit would have been a pretty good upgrade.
Even if it didn't support x86 properly, just having the 64-bit in 1998 might have been better. But then AMD beat them.
And the whole reason AMD did well is because their chips could run existing software with no performance penalty.
Yeah.
But that was something good to have because we now had 20 years of software written for that processor design. By 2001, is that when? Yeah. By 2001, when Itanium shipped, we were just firmly in x86 everywhere. In 2008, HP actually started paying Intel to keep Itanium alive for its HP UX operating system and applications.
HP really takes the sunk cost fallacy seriously.
Yeah, I know. They worked really hard on this, and then, what was this? 7 years after Itanium starts shipping, HP's like, okay, can you pretty please keep making it? Please, don't leave all of our software in the dust. The amount to keep supporting Itanium reached $440 million by 2014. And in 2010, HP and Intel signed a different agreement, which was worth around $250 million, to continue updating Itanium until at least 2017.
Jeez.
So HP's like, can you just give us, another couple years here, please?
Is this why HP laptops are so expensive? They're still trying to recoup the costs of Itanium?
Yeah. It's hard to get a grasp on just how costly of a mistake this whole project was. Intel sunk in, I'm sure, billions of dollars, and HP was sinking money into it well after everyone else had already realized there was no point in this.
What was HP doing? They could have spent that money to just rewrite their stuff.
The whole premise of Itanium was that Intel and HP would both benefit, right? That Intel would make these advanced processors, and then HP would develop the software for it and also sell servers with the chips. So Intel would get money from HP buying the chips, and HP would get money from companies and schools and other organizations buying their servers with the Itanium chips.
Who was buying their servers?
Not many people. That's the problem.
What was HP's hope here?
I don't know. But in 2017, Intel released the Itanium 9700 series, which was the final generation of Itanium. It wasn't a major improvement in any way. It was just a clock boost, basically.
Did they finally reach 1 gigahertz?
Legend has it they're still trying to do that. In January 2020, Intel stops taking orders for Itanium processors. And then
they were still taking orders?
Yeah, HP was still buying them.
What is HP doing?
I don't know. Has anyone checked on HP? I mean, honestly, if you think about it, the profit margins on printer ink alone probably paid for all that. And then finally, in December 2020, HP ends shipments for its Itanium i6 servers.
Again, who was buying them? Just some really hardcore Itanium fan.
Yeah. Yeah, there's just one dude with all these servers in his basement. He keeps trying to invite people over to show how quickly he can search through.
Math.
Yeah. It's like, look, I've got a database of all these numbers in them. You got to come over and see. Yeah. So that's really the end of Itanium right there. It's still deployed in some places. HP still has support contracts in place where they have to keep their operating system and applications updated for a little while longer. But really, that's the end of Itanium.
When was the last generation released?
It was released in 2017.
Oh.
Yeah, so the final generation of Itanium, which was nicknamed Kitson, was 32 nanometers. It ran between 1.7 and 2.6 gigahertz with 4 to 8 cores. And that ran at 130 to 170 watts.
That's a lot of power. For not a lot of power.
The chip design is simpler, but it uses more power, and it also needs more specialized compilers and software, which never materialize. That's part of the issue here. The whole chip design is based upon the premise that RISC processors were eventually going to hit their limit in what they could do.
Mm-hmm.
And that never happened. But yeah, so that's it. Very sad.
Oh well, I'm happy with my AMD 64 architecture.
Yeah, it all worked out in the end.